All right, so this video is on the divisibility test for division by 11. So this one's a little different than some of the other ones we've seen. So I've got it up here. So I've got a number is divisible by 11 if the sum of all the odd position numbers minus the sum of all the even position numbers is a multiple of 11. Okay, so let's see what that means. And I just want to this one needs some explaining here. So let's do this through a couple of examples. So I'm just going to show that, what do I have, 9, 3, 4, 12 is divisible by 11. Okay. Now, be very, very careful with this. The odd positions are going to be 1, 3, and 5. So these are the odd, and I'm going to do in blue here. And the even positions are 2 and 4. Okay? So it's basically every other one. And we get that. So don't read this as the sum of the even numbers and the sum of the odd numbers. That's not what it is. All right. So now here's what I'm going to do. The odd position numbers are 9 plus 4 plus 2, right? 1, 3, and 5 positions, minus 3 plus 1. Okay. All right, and in this, again, I get, let's see, I get 13, 15 minus 4 is 11, okay? And I'm checking to see if it's a multiple of 11. And since 11 is a multiple of 11, then yes. Yes, okay. Right, and for example, you could double check this if you wanted to and do division by 11 to see if that works. All right, let's do another one here. And I'm going to do 208, 273 divise by 11. Okay. So here's what I'm going to do. The odd positions, 0 plus 2 plus 3 minus 2 plus 8 plus 7. Okay. So again, there's the even positions and the odd positions are those two, right? So I'm not doing even and odd numbers, I'm just doing the even and odd positions. So there's 5 minus 17, which is negative 12. Okay. And that's not a multiple of 11. So even though we haven't done a lot with negative numbers yet so far, you can be negative. So if this was negative 11, this would have worked fine, but this is negative 12. So since negative 12 is not a multiple of 11, 208, 273 is not divisible by 11. Okay. Good, so there's a couple of examples. Now the other thing I want to do here is I'm going to do a proof. And this one's a little different again, but it's basically different because the actual test is different. So this is going to be proof for a 6-digit number. Okay, now, So what we're going to do is I'm going to write, let's have n be the number that we're looking for, right? So let n equal 100,000 A, 10,000 B, 1,000 C, 100 D, 10 E plus F. Okay. So if I do this, then A is 2, B is 0, C is 8, D is 2, E is 7, and F is 3. Okay. All right. Now, since we're trying to, this is what we're trying to do, is we're trying to get this thing set up. So this seems to be a little bit weird. So the odd positions, so this is odd, oops, not add, odd, 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 are the B, D, and F. Okay? And the other ones are even. So what I need to do now is I'm going to rewrite is the following way. I want, let's see, the best way to show this, well, let's see, I'm going to need this. I want to see where we're going. Let me put it that way. This is often a thing to do. Right, so I'm going to want to get the odd positions is going to be plus B plus D plus F, and my even positions are A plus C plus E. Okay. So here's what I'm going to do is, for example, I'm going to split off. I want a B here, so I'm going to have 9999B plus B. So that plus that gives me 10,000. Right. I'm also going to have D, which I'm going to split one of those as 99D plus D, and then my F goes there. Okay. Right. So just to pause again, right? This plus that is that. So all I'm doing is splitting these into two pieces. 99D plus D is 100D, so I'm just splitting that into two pieces. And then F I'm going to write there. Okay. Now A is a little different here. A, I want a minus here, so I need to add an extra 1 so we don't have too many. So I've got 100,000 1A. So that minus A is 100,000 A. 1001 C minus C is 1000 C. And then I have 11E. 11E minus E, it gives me 10E. Okay. So N, instead of writing it like this, I'm going to write it like that. Okay, so that's the first part. This is a little tricky here. We're going to be able to do this. All right. Now, here's the other thing. I'm going to argue that these are all divisible by 11. Okay, so let me just show you this. This is going to be need a little piece of scratch paper here. So I'm just going to go ahead and do the long division because I'm going to want this in here. So 11 doesn't go into 10, goes into 109 times. Subtract 1 left over. Doesn't go into 10, so I write that. Bring another one down. 9 99, 11, 1. Okay, so this is going to be 11 times 991. I'm going to write that down real quick. 11 times 9091. Okay, maybe you can see this one, but 11 into 9999 is 909. So 9999 is 11 times 909. And it really doesn't matter what this other number is, it's just that it's divisible by 11 and I get no remainder. 11 into 1001, 99111. So 1001 is 11 times 91. Okay, and then 99 is just 11 times 9. Okay, so this n now is, here's what I'm going to do. I have 1, 2, 3, 4, 5 things. 11 is all a common factor, so I'm going to write those out. So 9091a plus 909b, 0, 91c, that is 91 times 11, 9d plus e plus the stuff that I have up here. Okay. All right. Now, I'm just going to make a little note here. This thing is like my capital A from the divisibility lemma. So since A is divisible by 11, because 11 is a common factor, then n is divisible by 11 if and only if b plus d plus f minus a plus c plus e is divisible by 11. This is all by the divisibility lemma. And that's our test. That's what we were trying to show. Okay. This deserves a little recap again. Okay, so we're going to try to prove this for a 6-digit number. So I can write the 6-digit number, capital N is going to be my number. And here's how I break it up into 6 digits. Right? Just have powers of 10 times each one of them. Okay, now remember, we want to try to get to this, because that's what our test is. The odd position numbers are B, D, and F on my number. A, C, and E are the even position ones. And so to get these, right, I add an A and subtract an A. And here I just B, and that plus that gives me that. For C, I add a C and subtract a C. For this one, I split into 99D plus D. The same thing, E plus an E minus an E, and the F just goes right there. Okay, so I'm going to rewrite N as this thing plus this thing. And then I note that these 1, 2, 3, 4, 5 terms are all have 11 as a common factor, and we factor out 11. So this thing here I call capital A, which refers to the capital A from the divisibility lemma. So since it's a common factor, it's divisible by 11. And by the divisibility lemma, if this is divisible by 11, the original n is divisible by 11. Okay, good. So again, take away from this as this is the flavor of how we are proving these things. This is the toughest one we've seen. So see if you can sort of wrap your head around it a little bit. All right, so that wraps up divisibility by 11.